Okay, so good evening everyone. My name is Alon Kaduri and I've been working at Wix for about 3 years. Currently I'm the SSR team lead and I've been doing web development for about 10 years. So to get to know you a little better, some quick questions. How many of you are also front-end or full-stack engineers? Great. And how many of you are already using SSR or heard about it? Okay, great. So this is a high-level talk, and it will be relevant to all of you. We're going to talk about 3 topics. We'll start with search engine optimization, SEO. We'll talk about performance and how we do SSR for Wix Code. Okay, so you all have the products you're working on, and I talked with some of you about your products. This is what we've been doing for the past 3 years, and Ziv already did an intro to what Wix Code is. Don't worry, it's not a sales pitch, just to give you some context. So Wix Code makes it easy to build any web application. It gives you serverless coding, both in client and in server. You can set up a database. You can change your site behavior with APIs. And it's all done in the editor, in the Wix editor, with all the stunning design features, so you don't have to build the UI yourself. And that's all great for Wix, but it's a lot of headache for my team, for the SSR team. Because basically what our app was doing is taking a JSON representing the page that we currently need to render, and outputs an HTML. And with Wix Code on the site, this means going from rendering of static pages to running user code during the render, and then generating the HTML according to those changes. So we're going to talk about some of those challenges. But let's start with a subject that is sometimes neglected, and that's SEO. So we usually develop our site or our app with a desktop browser, and maybe we show it to our boss or to our partner on our mobile device. But we forget to check how bots see our site and how they experience it. This can lead to, of course, not being found on Google. And depending on your business, it can be very crucial. So by the end of this talk, you will understand how to make sure all of your site content is indexed by bots, how SSR affects performance, and how we did SSR for Wix Code. So this is Alexa Hill, and she's a Wix user. Well, not really, it's one of our templates. But let's say she's a Wix user, and she's a vocalist, meaning she's a lead and a backup singer, and she records her own stuff. And she relies on her site to showcase her work. And we'll use her site as an example throughout the talk. So if some potential client is searching Google for female vocalist freelance, how do we make sure they find her? The definition of SEO from Wikipedia is, and I'm going to read it, the process of affecting the online visibility of a website in a web search engine unpaid result, often referred to as natural, organic, or earned result. And you all know it, it's the search results of Google, not the one at the top with the ad, not the one you paid for. And we're going to talk about the technical challenge of having all your content indexed by Google. We're not going to talk about how or why Google ranks this content, meaning where it appears in the search results. That's a whole different subject. Okay, another important thing is to make sure that social media bots can see your content as you intended. When you share a link in Facebook, in Twitter, in WhatsApp, there's actually a bot behind the scene that goes to the page and extracts the data and shows it in the UI specific to the application. Okay, so how does Google index your site? So in the past, bots were making an HTTP request to your site and using only the raw content to get the content on the site. They weren't interpreting the content like a web browser running JavaScript does. So that was in the past. With the rise of Ajax, there were more and more sites that had their valuable content loaded with JavaScript. And all those sites weren't appearing in the Google search results. So in 2009, Google started with Ajax crawling. And this is how it works. The bot makes the request to the site. And the site responds with the HTML. Now, if you have a single page application, the valuable content is not inside. What you do is you return a meta tag telling the bot, this site is created dynamically. The bot then makes a second request with a special query parameter called escape fragment. So it makes a request to the escaped version of your site, and it expects to get back the HTML version of your site response with all your content. This escaped fragment version doesn't need to include any CSS or JavaScript, because again, the bot doesn't run it like a browser, it only reads the content. Why escaped fragment? Anybody knows? Why this name? Okay, so that's why you're here.
For the server to know that he only needs to return an plain HTML and not more than that.
Yeah, that's part of the answer, that's right. It's called escape fragment because web application use the fragment part of the URL, that's everything after the hash, to maintain state in the application. Which page am I, which pop-up is open, they usually use the hash part. Now, the hash part is not being sent to the server. So by transferring it to, from the hash part to a query param, the server can get your state. And also, what Ziv said, that's the way for the server to know that that this is a bot and it needs to return the escape version, the HTML version. And it all was good and well until 2015, when Google announced it will deprecate Ajax crawling. They did it because they wanted first for their bot to act like a real user, to get the same experience, same as a user with a browser. And they also wanted to spare the site owners from having to generate this HTML version. It was usually done in the past with headless browsers. 2016, Wix started developing SSR, the current solution. We talked before, we had a few attempts to do it. I'm talking about the last one who succeeded. And now we're going to take a small detour from the timeline and talk about SSR. So we use React in Wix, and React lets us run the same code both in the server and in the client. It's called isomorphic code or universal code. It's basically JavaScript code that runs both in Node and in the browser. So in the browser, you give React your top-level component, let's call it my site, and an HTML element. And usually, if you're working only in the client, your HTML element is an empty div. And you tell React, please render my site into this div. In the server, you give the same top-level component to React, but you tell it, render to string. And then you take this string representing the content of the site and embed it in a template of the HTML response that you're going to return. By the way, stop me and ask questions. Raise your hand if you have questions during the talk. You don't have to wait till the end. So here's the client-side flow. The browser gets a response. Again, it's with an empty div. The actual content is not there. The browser then downloads all the JavaScript, executes React, and then the site is visible and interactive, right? You can see it, and you can click on things, and the application works. In the server flow, in the SSR flow, you get a response with all the HTML inside. So now the browser renders the page, all the images and all the DOM elements, and the site is visible. The browser then downloads all the JavaScript again and execute React, and then the site is made interactive. Yeah?
So my question is basically about the switch from the server-side rendering to the client-side rendering.
Mm-hmm.
The point where we have this template, the HTML, and then React starts working. Like, how do you combine the data? Let's say I'm rendering a specific component or anything, it renders over it. It relates what
Okay. So you're asking how does React know to attach to the DOM generated in the server? Did I understand correctly? Okay, great. So let's talk about React 16 because it worked differently in React 15, but we have React 16 now. React 16 has a function called hydrate. So you give it your top-level component, which you generated in the browser. You built all the components and you prepared all the props, and you give it the same container. Now, when React, it has the virtual DOM, and then he goes here and he says, "Oh, I already have DOM. Let's see if it's the same." And that's the hydration process. It goes on each DOM element. If it's the same, it says OK. If you have in your component like an on-click handler, then it goes to this DOM element and adds a click handler. This process is called hydration. So you hydrate the static DOM generated from the server with the client code.
So it only fills the differences?
Sorry?
So it only fills the differences with the
Yeah, so differences, if you have the differences in content, let's say you have an extra DOM element generated in the client, it will add it. If you have the same DOM element but the content is different, it will update it with the client version. It's not a full comparison. So if you have the same example, if it's the same div but with a different style, let's say in the server I rendered 500 and in the client 450, it will stay 450. React doesn't match every property, every attribute on the DOM element.
Does the hydrate function also deals with data fetching? For example, I did an AJAX request to component 1 to get some data from server.
So the hydrate function is the same as render. It runs all the lifecycle methods of your components.
So data will be fetched twice from the server.
Yeah. We implemented our own mechanism for preventing that, because we said we already fetched the data in the server, we just pass it to the client. It's not part of the presentation, because I was planning to say it later. We already had a talk about SSR in our meetups. You can check it out in the YouTube channel in Wix Engineering. So I'm not going to talk so much about here about the implementation of SSR, but feel free to catch me after the talk, and we'll talk about all these subjects. Yeah, so we talked about server-side flow, and we said that now we see that compared to the client flow, here the site was visible and interactive at the same time, and here we have a separation. So this separation between the time the site is visible and the time the site is interactive is called perceived performance, and that's what SSR gives us. It doesn't necessarily have to be React, the concept of SSR. And it's made possible by two things. First, the server doesn't need to download and parse all the JavaScript for each request. We load the server once, we load all the code once, and we use the same code for all requests, so it's much faster. The second reason is that we can probably render faster in our server, especially faster than mobile devices. So we can generate the HTML much faster than a mobile phone can. Even if the site is not yet interactive, meaning not all the JavaScript loaded, it's still visible, and the user can still see it and start making choices what it wants to do next. Okay, so perceived performance is actually a measure of how quick the user thinks your site is, and it's often more important than the real speed of the site. This is what SSR did for us at Wix. So you can see the drop. It's a good drop. It's talking about loading time over time to visible, and it's improvement of about 60 to 70% across all percentiles. And of course, this talks about only about the first page load. Any other navigation inside the site happens like any other single-page application, only the client. We don't go to the server to paginate inside the site. OK, going back to the timeline. So 2018, a few months ago, Google announced that it will start. They promised in 2015 that they will deprecate Ajax scoring, and they did it a few months ago. So in our system, monitoring system, we actually saw a drop in traffic coming to the escaped version of the sites, and a rise in traffic to regular sites, but with a Googlebot user agent. And their announcement said, and I'll read a sentence here, Googlebot is generally able to render and understand web applications just like modern browsers. So that's a good thing, right? We can now serve our client app to the bot, and it will render it and index on the content, and everything will be great. So not so much. Google is using Chrome 41, a modified version of Chrome 41 as their bot, as the crawler. That's a 3-year-old browser. And it doesn't always manage to render the site successfully. It doesn't have full support in ES6. It's missing some CSS support. It has unknown timeouts or time budget. Google doesn't tell us what's the logic behind and how they do it, but we know from tests that they can't wait forever for each page to load, for each resource to load, because they need to crawl the entire web, the Google. And they also have a concept of budget. So if each page of your site takes a long time to fetch and render, then sometimes it won't get to all of your pages. Let's say you'll start from the home page and start calling pages, and imagine that you have some budget for your site. If you waste a lot of time on each page, it won't crawl all of your pages. Also, it doesn't wait for WebWalker to finish. So if you use a WebWalker and the result of the WebWalker should be is changing the content, the bot won't wait for the walker to finish. And let's say a simple example, you have a walker that does 1 + 1 and writes the result to the DOM. So the bot won't wait for the walker. OK, remember Alexa. She relies on your site to get discovered and get jobs. So what do? We have 4 things. We can make sure or verify what Google sees. Fetch and render. So this is the Google Search Console. And if you're working on a site or an application, you should probably know it. And once you are verified as the site owner, it lets you, it gives you tools and reports that help you measure your site traffic and SEO performance. Specifically, this is the Fetch as Google feature. And it lets you see how Google on the left sees your site and how a visitor sees your site. In this case, it's all good. They look the same. And at the bottom, they show you resources that the bot couldn't fetch. Maybe you blocked it at some level. Maybe it's in your robots TXT. But it tells you about resources that it couldn't fetch. So that's the first place you can go and make sure that your site is visible to Google. You need to remember that this view, it's optimized for speed. So because it's a user-facing feature, it's optimized for speed. And the actual bot that crawls the sites, it has a bit more tolerance for slow sites. It also has a mobile view. And here I wanted to mention that since 2015, there are more searches being made on Google from mobile devices than on desktop devices. So also, really recently, I think 2 months ago, Google announced that they will start to crawl the mobile version of your site. So you need to make sure that all your valuable content are in the mobile version of your site. OK, so the second method we have is site search. You probably know it. You can ask Google to search for content in a specific site. So in this example, I went to Alexa's site, and I searched for the word meetup, and it wasn't there. And I searched for the word singer, and it's there. So this is also a way you can make sure that all your valuable keywords are indexed by Google. The third is Google cached copy. There's the little triangle next to the search result, and if you click it, you get to see how the cached copy in Google looks like. And it lets you see a full version, a text-only version, and the source code, the source itself of the site. And of course, if all else fails, you can always download Chrome 41. There's a link in their documentation. You can download it and debug locally. So how does server-side rendering help us with SEO? So to recap, we had the second request for the escaped fragment version. Traditionally, I mean, in the past, we had a Scala server here at Wix that was responsible for returning result. We actually had a duplicate rendering logic. So for the same JSON representing the site, we had a React app written in JavaScript that knows how to render the site, and we had a Scala server who knows how to render HTML specifically for bots. And you remember that in SSR flow, the response that you get contains already all the HTML and the styles of the site. So really all what we had to do is tell bots, now go to our node server. We don't need the escape fragment version anymore. We return an HTML version, plus it's already styled, plus all the JavaScript. And the benefits are clear. First, we don't rely on the bot to run all the JavaScript successfully to get all the content. It's already there in the response. We maintain only one rendering logic, so we deprecated the Scala server. And it's fast if it's done right, and that's also important for bots. So up until now, we talked about rendering of regular sites or static sites. Now let's see what we do when there's Wix code on the site. So let's say Alexa goes to the editor and opens DevTools, and Ziv already showed it. There's a little IDE here that you can actually write code, and you can change content, and you can change UI, you can change functionality. We'll let you do basically everything in the site. So when we designed Wix code, I think it was about 3 years ago, or maybe a bit more, we decided that we're going to run the user code inside a web worker. And the reasons were that it's an isolated environment. There's no access to the window or DOM there. It's a different thread, so it shouldn't block the UI. And it was a relatively new feature, which was already supported by the major browsers. And if you remember the timeline, this was before we had SSR. So when we wanted to run sites with Wix code in the server, we got this error. There's no worker implemented in Node. So we created our own. Node Web Worker. It's a Node.js add-on written partially in C++ and partially in JavaScript. It uses the V8 isolate, which is the JavaScript execution environment. It runs on a different thread, and it's a controlled environment, meaning there's no Node.js specific modules inside. There's actually nothing, no file system, no OS, no nothing. We did give it an option to go outside to the web, because user code wants to fetch resources from wherever it wants, but it's controlled by us. And we only had to implement the web worker API, which is mainly listening to messages, sending messages, and terminating the worker. It's not open sourced yet, but there are similar projects out there which are open source. One of the great benefits of this project is that we can take a snapshot of the worker. Our snapshot actually serializes the entire V8 heap of the process with the parsed code, the AST, the global variables, and the compiled code, the actual byte code. So we take the snapshot just before, after the worker has loaded, all the code inside has loaded and has been executed. But just before, we load any user-specific code. So we actually take a snapshot of the, let's call it the worker with all the infrastructure, with all our code. That way we can use the snapshot between sites, between requests. Some of the pitfalls that we had. So since this worker is it's a JS environment that we created from scratch to make it secure. So we had to make sure we give it all the globals and everything it needs to have inside. So if a regular worker in the browser has I don't know, a fetch function, we also needed to have a fetch function implemented in our worker. And of course, we had to deal with bad or malicious user code, because if the user writes bad code and he loads it in his browser, that's okay. It's only his browser. It might get stuck. If it's on our server, then it's worse. So we actually had to implement timeouts and other measures of dealing with this kind of code. Did it quickly. There were no questions. So to sum up, SSR is very good for perceived performance. You can use it for SEO to have all your content indexed by bots. It can run user code, and it can actually generate any kind of website. And you can come and talk to me later about your website, and we'll see if SSR can work. Thank you.